Hi everyone, in this video we are going to continue talking about probability, the addition, multiplication, complement, conditional probabilities, and Bayes' theorem. So for this first activity, I'm going to want you to roll a six-sided die 10 times, note the outcome each time, and then based on your results, find the following probabilities. So you should have then 10 things in your sample space. If you don't have access to a six-sided die at home, then you can use the random dice roller. So if you click on the link, which is also provided in your notes, then you can access that dice roller and just hit roll 10 times and then note the outcome each time. I'll share my results with you. So here are my results. When I roll my dice 10 times, I got these numbers. So now I can answer this probability questions. So the probability of getting a 4 for my sample space, this is my sample space. So I got 4 1, 2, 3 times. So the probability then will be 3 out of 10. So this is different than if you just roll a six-sided die. The probability of getting a 4 will be 1 out of 6. But because we are changing the experiment, right, we are rolling a six-sided die 10 times, and those outcomes become our sample space. So now here, the probability of getting a 4 or a 5, we're going to add this probability. So it's going to be the probability of getting a 4 plus the probability of getting a 5. Now looking at my sample space, yours will be different depending on your results, right? We are all going to have a different sample space. So the probability of getting a 4 is still 3 out of 10. And then the probability of getting a 5, well, out of my 10 times, how many times did I get a 5? 1, 2, 3 also. So some of you may have gotten 1, some of you may have gotten no 5, so it'll be 0. So this, now can 4 and 5 happen at the same time? No, right? When I roll a six-sided die and it lands, the face that is up is either going to be a 4 or some other number or a 5, but I'm not going to get a 4 and a 5 at the same time. So my probability is just 6/10, and try to reduce it. Every time you get a fractional probability, reduce it to lowest terms. So divide by 2, so this becomes 3/5. Now what about the probability of getting 4 or getting an even number? Now the probability of getting a 4 is still 3 out of 10. And now the probability of getting even. But now here, notice that 4 is itself an even number. So if I just do 3/10 plus, right, the probability of getting a 4 is 3 out of 10. What about the probability of getting even? For my sample space, how many times did I get an even number? 1, 2, 3, 4. So I got 4 out of 10. But I am now double counting the 4s. So I need to subtract the times that I got a 4. That is an even, right? Because 4 is an even number. So this is just going to be 4 out of 10, which is 2/5. So this is essentially the probability of getting a 4 and being even. So because 4 is an even number, I am essentially double counting those. So I want to get rid of any double counts. And so these are my probabilities, which brings us to, so in this case, the probability of 4 or even is really the probability of 4 plus the probability of even, and then minus the probability of 4 and even. So I have to subtract the double counting. So, which brings us to mutually exclusive events. So 4 and 5 are what we consider to be mutually exclusive. So mutually exclusive events are events that can only occur once, so they cannot occur at the same time. And if they're not mutually exclusive, that means that they can occur at the same time. So like I was saying with the 4 and 5, right? When you roll a dice and you look at the face that is up, is going to be a single number. So it can't be 4 and 5 because you only get one number. Versus the probability of getting 4 and even, well, like if you get a 4, that is an even number. If you get a 2, that is an even number. So those are not mutually exclusive. So that brings me to our definition. Let me fix this real quick. All right, so mutually exclusive events are two events that cannot occur at the same time. So they're also called disjoint events. So when they are disjoint, you have event A, event B, they cannot overlap. So A and B we say are mutually exclusive, or the other terminology that you may see is that they are disjoint. Now, when they overlap, like the being 4 and being even, right, those overlap of the number 4 is an even number. So then we say they are not mutually exclusive or not disjoint. And so when there's overlap, so we gotta, when we find probabilities, we need to get rid of that double counting of that overlap. So in our examples, the probability of 4 or 5, are they mutually exclusive? So the events are event A, we can say, is getting a 5, or sorry, getting 4. I guess it doesn't matter which one I say first. Event B, getting 5. So then these, they cannot occur at the same time. So this will be mutually exclusive. Versus 4 or even, sorry, then A will be getting a 4, B will be getting even. Are they mutually exclusive? No, right? 4 is an even number, so they can happen at the same time. Now this next set of examples, decide if the events are mutually exclusive, or the other word you'll see, disjoint. A student is randomly selected from American River College. So event A, the student is male. Event B, the student is a nursing major. So are these mutually exclusive or not mutually exclusive? So when you select a random American River College student, then mutually exclusive? No, right? You can have so you can say not mutually exclusive. The student can be male. Can be a male nursing major. So not mutually exclusive. Those can occur at the same time. Our next example, a card is selected from a standard deck of 52 cards. Event A, the card is an ace. Event B, the card is a club. So are they mutually exclusive? Can they happen at the same time, right? Can an ace be a club? And so I put the deck of cards just because sometimes we forget what everything is, or we may not be familiar with the standard deck of 52 cards. So we have 4 suits, and each suit has 13 kinds in each, right? From 1 being the ace to then 10, and then jack, queen, and king. And then you have the 4 different types of suits: diamonds, hearts, spades, and clubs. And so the card is an ace and the card is a club. Can they happen at the same time? Yes, you can have an ace of clubs. The clubs is the type of suit, and the ace is the number, so the 1 here. Well, depending on what game you're playing, right? So we can say that these are then not mutually exclusive, because an ace can be a club. So from the suit of clubs. So not mutually exclusive. Getting an ace and getting a king will be then mutually exclusive, right? An ace, if you pick one card out of the deck, it can't be both. It can't be an ace and it can't be a king. So those will be mutually exclusive, but being an ace and being a heart, those are not mutually exclusive, because as I can see here, there's an ace of hearts. So, and if it's helpful to refer to this deck of cards in the future, if you having a hard time remembering how many suits, how many cards, and what do they look like, then this might be helpful. Let's go to the next example. But first, let's write our addition rule for probability, the probability of A or B. So When you have two events A and B, the probability that A or B occurs is probability of A plus the probability of B minus the probability of A and B. So one key point here though is that if they are mutually exclusive, then you just have the probability of A plus the probability of B. What this means is that the probability of A and B is zero, right? When you get a probability of zero, zero means it never happens. So when they're mutually exclusive, that means A and B never occurred at the same time, which is what it means to be mutually exclusive. They cannot occur at the same time. So let's find these probabilities. For example, you select a card from a standard deck of 52 cards. Find the probability that the card is a 7 or an ace. So one of the questions we want to ask ourselves first is, because I see it's an or, so this is going to be the probability of 7 or ace. So based on my rule, it's going to be the probability of 7 plus the probability of ace minus the probability that A and ace occur. So are they mutually exclusive? So this is going to be the probability of 7 plus the probability of ace minus the probability that is a 7 and an ace. But looking back at our standard deck of 52 cards, the aces over here, there are 4 aces and there are 7s, and they cannot be, if you pick one card from the deck, it cannot be both an ace and a 7, right? So then we will say these events are mutually exclusive. So these are mutually exclusive. Therefore, the and probability is 0. So this is just the probability of 7. So what is the probability of getting a 7 in the standard deck of 52 cards? There are 4 7s. So 1, 2, 3, 4 out of 52. So the probability of getting a 7 is 4 out of 52. The probability of getting an ace is also 4 out of 52. And the probability of getting 7 and ace is 0 because they are mutually exclusive. They cannot occur at the same time. So there's nothing to subtract. So I just get 8 out of 52, and you should probably reduce that. So 8 out of 52, let's see, what does that reduce to? I think I can divide both of them by 4, giving me 2 out of 13. So this will be the reduced probability. Part B, find the probability that the card is an ace or a club. So this one we saw earlier that these are not mutually exclusive. We can go back to our deck of cards and see that there we have our deck of our suit of clubs and there is an ace. So these are not mutually exclusive. So let me write that. So ace and club are not disjoint, right? So not mutually exclusive. So that means they can happen at the same time. So then we're going to have the probability of ace plus the probability of club minus the probability that you get an ace and club. So what's the probability of getting an ace? 4. There are 4 aces in the deck of 52 cards. What's the probability of getting a club? Well, how many cards are clubs? And we can see, well, a club is a type of suit, and there are 13 kinds in each suit. So there are 13 out of 52 cards that are clubs. So we're going to say plus 13 out of 52 minus what is the probability that ace and club happen. So that is, there's just one suit of clubs and one ace in the suit. So then this is going to be 1 out of 52. And so add those up. They already have the same denominator. So 4 plus 13 was that 17 minus 1. So I'll have 16 out of 52. But make sure that you reduce that. So when I reduce it, we are going to get, let's see, well, I know 4 goes into both of them already. So 16 divided by 4 is 4, and 52 divided by 4 is 13. So I'm going to have 4 out of 13. So that is my reduced probability as a fraction. Pay attention in the homework. Do they want you to write it as a reduced fraction or do they want you to write it as a decimal? So follow the instructions given to you. So if it says leave as a fraction, make sure it's a reduced fraction. If it says write as a decimal, like oftentimes if they want a decimal in the homework system, it will say round to 3 decimal places, 2 decimal places, something like that. And so that means that you can enter decimal answers. Next example, you roll a single 12-sided die. Find the probability of rolling a number less than 8 or rolling an odd number. So for something like this, I want to first of all think of my sample space. And even with the deck of cards, right, the sample space, I've inserted this picture in here just because it provides a nice visual of what our sample space contains and you can refer to it. So anytime that you can get your hands on the sample space, do that. So when you roll a single 12-sided die, so what is your sample space? Your sample space is going to be the numbers 1 through 12, right? So there's our sample space, the numbers 1 through 12. Here we want to find the probability of rolling a number less than 8 or rolling an odd number. So probability of less than 8 or an odd number. So that means it's going to be the probability using our addition rule, the probability of getting a number less than 8 plus the probability of getting an odd number minus the probability of being less than 8 and odd. It's a good idea to always write the full addition rule, including the minus the probability of A and B. And then if they're mutually exclusive, you'll just know that that is 0. But I rather you write the full formula than assuming they're mutually exclusive and forgetting that. So always write the whole thing. If they're mutually exclusive, you'll find out that you won't need that, but I'd rather you not forget it. So what is the probability of getting a number less than 8? Now it's strictly less than 8, so that's going to be 1 through 7. So it'll be 7 out of 12 plus the probability of getting odd. So my sample space is 1 through 12. So how many odd numbers are there? So I have 1 is odd, 3, 5, 7, 9, and 11, right? So I have 1, 2, 3, 4, 5, 6. So the probability of getting an odd number is 6 out of 12. Now, can being less than 8 and being odd happen at the same time? So when you roll a dice, can it be odd and less than 8? Yes, right? So the ones that are odd and less than 8 are 1, 3, 5, and 7. So those are odd numbers that are less than 8. So I have 4 out of 12. So that means that these are not mutually exclusive, and I do have a probability. So let's combine those. They already have the same denominator, so just add them up. So 7 plus 6 is 13, minus 4 is 9. So I get 9 out of 12, reduce it, right? So divide by, looks like you can reduce by 3, so it's 3/4. So that will be our reduced probability. If you're asked to write it as a decimal, it will be 0.75. Okay, so when available, write out what your sample space is so that then you can tell what the probabilities are going to be. Our next example, which I'm gonna do it on the next video. And so we're gonna use this example to go into complements and the multiplication rule for probability. So you can read the example, try to maybe figure out on your own what you would do, and then go on to the next video, part 2 of this video series.